Good morning, everybody. Hope you're having a good spring break or week after spring break. So this section we're going to cover 13.3 and hopefully 13.5 at the same time. Maybe two separate videos. We'll see how long this first one takes us. So we're still dealing with sequences and series. But this time we're going to do something called a geometric sequence. So a geometric sequence is very similar to arithmetic, except we're going to be multiplying by the same number every time. So for a geometric, you're going to be multiplying by the same number every time. That number is going to be called the common ratio and is going to be noted by R. So an example would be 2, 6, 18, 54. This would be where my common ratio is the number 3. So again, geometric, very similar to arithmetic, except you're multiplying instead of adding. Keep in mind, you could be dividing by the same number, and that's when R is going to be a fraction. That R has a special name called the common ratio. And this formula actually is the recursive formula. So let's go ahead and write it down. The recursive formula for geometric, a sub n, remember a sub n is any random term, equals a sub n minus 1, remember that means the previous term, times R, the common ratio. And remember, when you do the recursive, you have to say where you start. So you need to say the a sub 1 number. The explicit formula, remember the explicit formula is the nicer of the two. A sub n equals a sub 1 times R to the n minus 1 power. And again, let's talk about what all these little pieces mean. A sub n is the nth term. A sub 1 is the first term. R is the common ratio. Ratio, not ratio. Ratio. Okay. Let's look at an example of one. So they're going to ask us a few things. Number one, they want us to find the nth term. This is code for find the formula, right? Formula. Then they want us to find the ninth term, a specific term, and then they want us to find the recursive. So part A, let's find the explicit formula, basically, is what that's saying. Well, the first thing we need to do is figure out the common ratio. So we need to figure out what number we're multiplying by to go from here to here. A lot of times you can do that with the first couple terms. Actually easier to look at the second and third. The easiest way to go from 9 to 81/10 implies that my R has to be 9/10. So if I go to write my formula, a sub n, I'm using the explicit, a sub 1 times R raised to the n minus 1 power. So there's part A. That's my explicit formula. For part B, I actually want to find the ninth term. So I actually need to plug this into my calculator. A sub 9 equals 10 times 9/10 to the 8th power. Notice you do n minus 1. And plugging this into your handy dandy calculator, you get that decimal. For part C, they want us to find the recursive formula. So the recursive formula says a sub n equals a sub n minus 1 times the common ratio, where a sub 1 equals 10. That's the recursive formula. So we have the explicit formula, we use the explicit formula, and we also found the recursive formula. So just like when we added up terms of an arithmetic, we can add up terms of a geometric. That's called the sum, summation, series, another name for it. So we have a formula, remember, S sub n is the sum of the first n terms. Remember, you can actually add up the terms, right? You could add them all up manually. You can write it in summation notation. That's a fine way to do it. Or there's a really nice formula. So S sub n equals a sub 1, the first term, and I like to put the second part in parentheses, 1 minus R to the n over 1 minus R. This will be the sum of the first n terms. So if they say find the sum of the first 10 terms or 20 terms or 30 terms, this is the process you would do. Let's look at an example. They want us to find the sum of the first 15 terms, and all they're giving us is we're using 1/3 to the n power. Well, let's find some terms. Well, the first term is pretty easy to find, 1/3. The second term, let's see, if I take the previous term and multiply by the common ratio, right? That looks like that's going to be 1/9, 1/27. So you can right off the bat see that R is 1/3. So let's see, they want us to find the sum of the first 15 terms. So they want us to find S sub 15. This is going to be the first term times, using the formula that we just had. Grab that formula from when I wrote it down. 1 minus 1/3 to the 15th power all over 1 minus 1/3. It's kind of ugly, got a bunch of stuff going on. Let's see, this is going to be 1/3. 1 minus 1/3 to the 15th power. Well, 1 minus 1/3 is 2/3. I'm going to plug this whole thing into my calculator. This becomes 1/3 times 1.5, or 0.499 repeating, or 0.5. So that would be the sum of the first 15 terms. So if you added up the first 15 terms, that's the number you would get. So it's a little bit weird with geometric, because geometric you can actually sum up even if you have an infinite number of terms, which sounds really, really strange, right? There's a couple pieces you need to know. Number one, the R value is a fraction, less than 1, so R has to be between 0 and 1. All right, so you have to have a fraction, well, I should say the absolute value of R has to be between 0 and 1. And then you can actually add it up, which sounds, again, really, really weird. So again, mathematically, they could write the summation, but notice the summation is to infinity, but it's a really nice formula. If you want to sum up, by the way, this sum is actually just represented often as just S, no S sub n because they don't have a number to add to, so they just call it S. It's the first term divided by 1 minus the common ratio. Pretty weird. It's actually an easier formula if you sum up an infinite term rather than a regular term. There's a couple additional pieces we need. If it has a sum, we say that it converges. And if it has no sum, we say that it diverges. So again, this is if R is a fraction. And this is if R is bigger than 1, right? R bigger than 1, it diverges. All right, so here's an example. Determine whether the geometric series converges or diverges. If it converges, find its sum. Well, here's my common ratio. So right off the bat, we know that it converges. So let's figure out the sum. The sum is the first term, which is 2, divided by 1 minus 2/3, which is 2 over 1/3, which becomes the number 6. It's a little bit crazy that, if you added this up, it would just turn into the number 6 for an infinite amount of time. Just keep adding. So pretty crazy. All right, moving on. Looks like we have time. We're going to do the next section. Binomial theorem. So right off the bat, the binomial theorem, something you may have seen before in your previous math classes. Looks a little tricky when you first see it, but it's actually really, really straightforward. What it is, it gives us a way to expand really high powers. So for example, if I asked you to do x plus 3 to the 7th power, you would not want to do it 7 times, right? You would not want to write this as x plus 3 times x plus 3 times x plus 3 times x plus 3 times x plus 3. Let's see, how many is that? 1, 2, 3, 4, 5, 6, 7. That would be very, very problematic if they ask you to do that. So there's another way to do it. It's called the binomial theorem. It's a way to expand it. Again, you can do it by hand if you want, but that wouldn't be very much fun. So the first thing we need is some notation. This is read n choose j, and the formula is n factorial. Remember, n factorial means n minus 1, n minus 2, and you keep going. So n factorial over j factorial times n minus j factorial. Let's do a couple examples. Let's do 3 choose 1. All right, so this is going to be 3 factorial over 1 factorial times 3 minus 1 factorial, which is 2 factorial. So this is going to be 3 times 2 times 1 over 1 factorial is just 1. 2 times 1, hopefully you see those two cancel out, so you get the number 3. Why don't you try to calculate the other two just to make sure you can do it, because you do need this factorial. And then I will put the answers on my answer key when I post it. All right, so let's see how we use the binomial theorem. So here's the theorem, and I know it looks crazy when you first see it. Believe me, it's actually much, much easier to use in person. All right, couple comments. This is your N. All right. This represents this X, and this is your A value. So all we're going to do is use this pattern. And again, if you look at the pattern, it looks crazy. So hopefully you'll see the pattern when I start expanding this. So this is going to become 5, choose 0, x to the 5th power, 2 to the 0 power. These two powers should always add up to 5. Plus 5, choose 1. Now here's the trick. You take a power away from the first term and you give it to the second term. Plus 5, choose 2, x cubed, 2 squared, plus 5, choose 3, x squared, 2 to the 3rd. Remember, these two numbers should always add up to 5. Plus 5, choose 4, x to the 1st, 2 to the 4th, plus 5, choose 5, x to the 0, 2 to the 5th. So that's step 1, is to expand it. And now we just got to make it look pretty. We just got to make it look nice. Turns out 5, choose 1 is 1. Anything to the 0 power is 1, so we get 1x to the 5th. That's our first term. Plus 5, choose 1 is 5. 2 to the 1st is 2, x to the 4th. 5, choose 2 is 10, so this becomes 10 times 2 squared is 4 times x cubed. Again, all we're doing is making it look pretty. Plus 5, choose 3 is also 10. 10 times 8 times x squared, plus 5, choose 4 is 5 times 2 to the 4th, 16 times x, plus x to the 0 is 1, and 2 to the 5th power is 32. And again, one more time, making it look pretty. X to the 5th plus 10x to the 4th. My pen's running out, I think. Plus, let's see, what do we get there? 40x cubed plus 80x squared plus 80x plus 32. There's the answer. Now, I promise you, if you took this and multiplied it 5 times and got all the way down, everything pretty, it would work out. This would be your answer. Don't believe me? Try it on your own. All right, the other thing they're going to ask you to do is they're going to ask you to find a specific coefficient. They're going to say, what is blank coefficient? So, given this expansion, they want us to find the y to the 8th coefficient, right? So, let's just do a couple of them just to show you where that would be. So this is going to become 10, choose 0, the first term to the 10th power, the second thing to the 0 power. The next term would be 10, choose 1, the first thing to the 9th power, the second thing to the 1st power, plus 10, choose 2, the first thing to the 8th power, the second thing to the 2nd power. And you could keep going, but notice they only wanted a specific one. They wanted this one, right? So I need to do 10, choose 2. So this is 10 factorial, 2 factorial, 8 factorial. Again, I'm going to calculate this number right here. All right, this becomes 2 to the 8th, y to the 8th, times 9. Let's see, 10 factorial is 10 times 9 times 8 times 7 times blah, blah, blah. 2 factorial is 2 times 1. 8 factorial is 8 times 7 times 6. Hopefully you're cool that all of this cancels out. So I get 90 over 2, right? 10 times 9 is 90. Times 9 times 2 to the 8th, y to the 8th. And when you multiply all this out, this is what that term would be after all your multiplication. So if they ask you for a specific term, you don't have to do the whole thing, just do part of the problem. So I'm going to have you try. You try to find the 6th term in that expansion. That means 1, 2, 3, 4, 5, 6th term. And if you want to know another way, there is another way. I gave you the books that you can read. There's something else called Pascal's triangle. It's a really nice way to do it. If we had time, I'd actually show you, but unfortunately we don't, so we're doing it the way that the book does it. Again, if you want to read how to do it, do that. Be sure you're working on your homework. Be sure you're keeping up with all your stuff, and hopefully you're having a great spring break. See you later. Bye.